All right, so we're picking up with 1.7, and we're going to talk about this introduction to perimeter, circumference, and area. Perimeter.
Should we write this down in our?
Yeah, well, just in your notes. Circumference and area. All right. So, what is the perimeter? What does the perimeter tell us? When I say the perimeter of a figure, what am I talking about? Yeah, here.
You walked around the edges.
So it's the length of all the edges put together. Okay, so it's the measurement around the figure. Measurement, and it's of length, right? Of length around the figure. Around the figure. All right, circumference. Well, when I'm talking about circumference, what figure am I talking about? It's a very specific figure, a circle. So we're talking, so circumference, another way to say circumference, right, is the perimeter of a circle. Okay, but circumference is a very specific sort of perimeter. It's the kind of the perimeter of a circle. Okay.
Why does that have to be special?
Circles are really special. They just are. You'll find out. They have pi in them. Okay, and then area. What am I talking? What are we measuring when we're measuring area? Length times width. What is that really telling us? It's telling us like how many square units is being covered the thing. It's like how much is so it's really those are like square units that an object takes up, square units of a figure. Okay. All right. So let's look at the green box. Now this you can put in your notes. Doesn't have to be in your that little black notebook. All right. So it says formulas for perimeter, area, and circumference. So perimeter is going to be P, area is going to be A, and circumference is C. So when we're talking about a square, okay, and let's just take a look at the figures that they're putting on here so that they say this. When I put these lines right here, what am I saying?
They're all equal to each other.
They're congruent. Yeah, they're congruent. And then if I put these in here, like this, what else are we saying? And I put these little boxes in each of the corners. What are we signifying? They're what?
90 degrees.
They're 90-degree angles, and they're all congruent too. So what is a square? A square has got congruent sides and congruent angles that all add up, that are 90 degrees each. Okay, so if I have a side, okay, so this is the side length is S. Okay, what is the perimeter of a circle? I'm not a circle, square. What's the perimeter of a square? Okay, so perimeter, I'm measuring around the outside.
Or S?
So yes, it's S plus S plus S plus S, whatever, 4 times, right? Plus S. So that's 4S. Right? If I add the perimeter, I could do it like this. But that's the same thing as 4 times S. All right, area of a square. How do I get the area? And then literally you just said something. So if this is S, then what's the area of this? S times S, which is? S squared. And that's why you should always have square units when you're measuring area. Because you're measuring, you're multiplying those, and you're getting units squared. All right, so now if we have a rectangle, right, and they're calling, which side are they calling it? They're calling it, I'm doing it different than what they got. Okay, they're saying, okay, we'll just length and width, okay? So what's the perimeter then of a rectangle?
Wait, we forgot to do the circumference.
I guess I'm just heading off to the side. Okay. So what's the perimeter of a rectangle? That's right there. Okay.
Length.
Well, the perimeter.
Length plus
2L plus 2W.
2L plus 2W. Now, whoops. That's bad. 2W. Because I could really say length plus width plus width, right? That's the same thing as 2L plus 2W. Okay? And then what's the area? Area of a rectangle. Length times width, so LW. Sometimes they'll call this base and height, and then an area will be base times height, okay? All right, and then a triangle. Here's a triangle, and they're calling the sides, they're not, okay, they're saying, I got A, B, C, and then I have this altitude in there, H. Okay, so what's the perimeter of this triangle? I'm going to measure around the outsides. If this is length A, that's length B, let's see.
A plus B plus C.
Yeah. All right, and then the area of the triangle is what?
1/2 base times height.
Base B times height. Okay, so that's a review, all right? You know, you guys have seen some of that before. And then circle. Okay, so our circle. And what's the difference between a radius and a diameter?
Radius is half diameter side.
Right, so this is radius, and then if I were to draw all the way across, the whole thing is the diameter. Okay, so the circumference of a circle, which is the measurement of the outside, is equal to what? 2 pi r, and the area of the circle is pi r squared. Now, and also the other thing, the circumference of a circle in terms of diameter is, so 2r is the same as a diameter, so pi d is also another way to say circumference, pi times the diameter. Because the radius is 2 radii, r is 1 diameter. Okay, all right, so let's, I want you to cover up the solution on example 1. Tell me what the perimeter is in example 1. I mean, you got to look at the figure, though. Yeah.
I'm
There you
sorry,
go.
how do I
Cover up the
see
solution, but look at the figure. You're covering up the figure. There you go. So look at the figure, but don't look at the solution. And tell me what the perimeter is.
Is it 34?
34. Yeah, because you can say 12 plus 12, right? 24 plus 10, 34. All right, and then the area, 60. And if I counted all those little blocks in there, I'd find that I have 60 blocks in there, right? So 60 square, 60 what? 60 inches squared, or square inches. Okay, so the units are important. The units are important. Okay, cover up the solution, but not the figure in example 2. All right, it says find the diameter, radius, circumference, and area of the circle shown at the right. Use 3.14 as the approximation for pi. You might need to get your calculator out. All right, so how big is that radius? Looking at that ruler.
13 no, it's
Yeah, be careful.
3 inches. Well, no, that's
40.
It lines up with 9 and goes to 13, right? So it's 4. All right, so our R is 4. So what is
D is 8.
okay, so D is 8. And then what's our circumference? 2 times pi times r. So what is that? You might have to use 3.14. Actually, you guys know you have a pi key on the calculator. 25.1. Yes. Okay. Now what's the area? Pi r squared. So you're going to hit pi. What's r squared? If r is 4, what's r squared?
16.
16. So 16 times pi is
50.26548
okay. So they're rounding on the 10th. Okay. So what is it? 50.2, and then what's your unit? Oh, 50.3
They did.
centimeters. Okay, but we're talking about area, so centimeters,
cubed.
not cube. That's
Squared.
volume. Volume is so squared. Yes. Okay, good. All right, and then now example 3. All right, cover up the solution, not the not the figure. All right, tell me how would we go about getting the perimeter on this guy?
Couldn't you just count up?
Well, you could you could count the base, okay?
Distance formula.
But what about, but we're doing perimeter, how are you gonna do D and F?
Distance.
Distance formula. Okay, so you're gonna have the distance formula. And, okay, so let's just look at this real quick and then maybe we'll do one example. Let's see, you guys get out of here at what time? Okay. Distance formula. So you'd have to do the distance formula between F and D and say, say, look at DF, you see how they're doing the distance formula, what do they get for the distance? 5 units, right? And then EF, what's the distance? You can go ahead and look at the solution.
4 square roots of 2.
4 square roots of 2. All right, and then how would you get the bottom? How about DE? How would you figure that out? You don't need the distance formula for that because that one you can count. If you can count the blocks, if the side lines up, you can count the blocks, right? It's only when it cuts across then you're going to do the distance formula. So what is the distance DE equal to?
7.
Yeah, because D is at x equal to 1 and E is at x equal to 8, so that's going to be 7 blocks. So then you just add all those up. You see the very last thing. And they didn't actually simplify. They just left the square root of 2 in there. They didn't turn it into a decimal. Okay, so they gave like what they call an exact answer. And you see what they're doing there? Look at this. They said that they added up the sides. They said 7. I need to erase this. 7 plus 4 square roots of 2 plus 5. How do I add that up? What's the rule for when you add stuff up in algebra? You must combine what?
Like terms.
Like terms. Is 4 square roots of 2 like these guys? No, so you cannot add those together. All right, so to simplify this, what do I end up with? 12 plus 4 square roots of 2. I could simplify this a little bit further by putting the square root of 2 in my calculator and getting a decimal. Okay?
I got 5.65.
That might be it. I mean,
That's
you know,
4 square roots.
because it's 4 times 1.141 or whatever that is. But anyway, in this example, they're not doing that. Okay. All right, and then let's look at. I don't think we're going to do the second part of this really. They give you a box there that tells you to, like a game plan. Okay, for solving these types of problems. And then looking at example 4, it says you have a part-time job at school. You need to buy enough grass seed to cover the school soccer field. The field is 50 yards wide and 100 yards long. The instructions on the seed bag says 1 bag will cover 5,000 square feet. How many bags do you need? Well, we're looking at this field in terms of what unit?
Yards.
Yards. So what do you have to do if you're going to be talking about square feet?
It's divided.
Divided by
Okay, hold on a second. So how many, you need to look at you need to convert the yards to feet. So if it's 50 yards by 100 yards, okay, so it's 50 yards by 100 yards, what is the measurement of this field in feet? How many feet are in a yard?
3.
3.
So it's
So how many feet is this?
150.
150 feet. How many feet is this? 300 feet. Okay, so what's the area of this thing? So take your calculator. What's 150 times 300?
45,000.
I got 45. Oh, oops. 45,000.
Okay, so 45,000. Yeah, that's right. Okay, now one bag is going to cover up how many square feet?
You need 9 bags.
Okay, and you need 9 bags. Okay, because you're going to divide that now.
You could actually do the yards and then multiply it by 9.
You could do, okay, well, okay, you could back into it, yeah. But at some point, you got to get it into feet, okay? All right, so, and then let's look at example 5 and 6. I think I'm going to let you look at those on your own, okay? So, again, these are just applications of the formulas for area. That's basically what the whole purpose of this section is. All right, so let's go. I've got 10 minutes. All right, we're going on to 2.1. All right, and 2.1, chapter 2. Let me stop this here.